Did China just copy SpaceX's Raptor engine? NASA engineers are stunned. This September, Landspace test-fired the BF-20, China's first full-flow stage combustion engine, matching SpaceX's most advanced tech. But it gets worse. Space Pioneer is now building a 300-ton kerosene engine that could exceed Raptor 3's power, a feat SpaceX hasn't achieved. With $2.86 billion pouring into Chinese space companies in 2024 alone, they're moving at unprecedented speed. The question isn't if they copied it, it's how they're already surpassing it. Let's dive right in. Let's talk about what just happened. On September 7th, Landspace didn't hold a press conference. They didn't live stream to millions. They quietly announced they'd test-fired the BF-20 engine, and the space industry went silent. Why? Because this wasn't just another rocket test. This was China entering the most exclusive club in aerospace: full-flow stage combustion engines. Only 3 entities have ever successfully fired this type of engine: SpaceX with Raptor, the Soviet Union decades ago with the RD-270, which never flew, and now Landspace. Not Blue Origin, not ULA, not even NASA has one in active testing. Here's what makes this design so brutally difficult. It uses 2 separate preburners, one fuel-rich, one oxygen-rich. Both run at extreme temperatures and pressures before feeding into the main combustion chamber. The engineering tolerances are microscopic. One miscalculation and the entire engine destroys itself in milliseconds. SpaceX spent years and countless failures perfecting this. Landspace did it in 3 years. The BF-20 currently produces 110 tons of thrust at half power. The target? 220 tons, matching SpaceX's Raptor 2 exactly. And they've already fired this engine over 30 times. They're not experimenting anymore. They're refining. You might be thinking, can they actually build rockets? Or is this just lab work? Let me answer with facts. December 14, 2022. Landspace launched Zhuke-2, the world's first methane-powered rocket to reach space. It didn't make orbit due to a second-stage issue, but it validated the concept. 7 months later, July 12, 2023, they launched again. This time, Zhuke-2 became the first methane rocket in history to reach orbit. Not SpaceX, Landspace. By December 2023, their third flight delivered 3 satellites into sun-synchronous orbit. Operational payload, paying customers, mission success. Now they're building Zhuke-3, a stainless steel beast powered by 9 Tianke-12B engines, fully reusable with a target of 20 flights per booster. First launch scheduled for 2025. On September 11, 2024, they proved reusability works. Landspace conducted a vertical takeoff and landing test reaching over 10 kilometers. The test lasted 200 seconds. But here's the crucial detail. At 113 seconds, they deliberately shut down the engine mid-air at 4,640 meters altitude, then reignited it 40 seconds later during descent. Engine restart during flight, the first time any Chinese rocket company has demonstrated this capability. The landing? 1.7 meters off-center on a concrete pad, 3.2 kilometers from launch. That's precision guidance that works. While everyone watches Landspace's methane engine, Space Pioneer just dropped a bombshell. According to a September 17th report from Xiaogan Daily, Space Pioneer is building a full-flow stage combustion engine headquarters with $4 billion UN investment. Local government is providing land, policy incentives, and funding. Here's what matters. They're building a test stand for 300 tons of thrust using RP1 kerosene and liquid oxygen, not methane. Kerosene. Nobody has ever successfully built a full-flow stage combustion engine running on kerosene. Not SpaceX, not Russia. The Soviets tried with the RD-270 in the 1960s, but failed. The technical challenges are immense. Kerosene burns dirtier than methane, creating carbon deposits that destroy turbopumps and combustion chambers. If Space Pioneer succeeds, they won't just match SpaceX, they'll exceed Raptor 3's projected thrust while using a cheaper, denser propellant that's easier to store. That's a genuine technological leap. China's commercial sector is moving fast, But state-owned enterprises are running an even more aggressive parallel program. The Academy of Aerospace Liquid Propulsion Technology is developing the YF-215, another full-flow staged combustion engine producing 200 tons of thrust with liquid methane and oxygen. Research started in 2010, design finalized in 2022. Throughout 2023, they conducted subscale tests on igniters, turbopumps, and control systems. By mid-2024, all subscale testing was complete. Recent reports indicate a partial full-scale prototype test has been conducted. Unconfirmed sources suggest a complete system test could happen before year's end. This engine will power the Long March 9, China's answer to SpaceX's Starship. And there's more. Emerging startups like Orenspace and iSpace are announcing their own full-flow programs. The entire Chinese space industry is converging on this technology simultaneously. None of this is accidental. In 2014, China opened its space sector to private capital, designating it for civil-military innovation. That single policy triggered an explosion. By 2020, China had over 160 commercial space companies with at least 25 actively developing launch vehicles. Investment data from Orbital Gateway Consulting shows the growth. $340 million in 2015 jumped to $1.685 billion by 2020, nearly 5 times increase. In 2024, $2.86 billion. But here's the critical part. As one recent report states, space power in CCP thinking cannot be separated from military power. This isn't just commercial ambition. China's space development is tied directly to strategic defense objectives. China now operates 6 active spaceports. That's not just launch capability. That's industrial-scale access to orbit with redundancy and flexibility. And there's Tiangong Space Station. Once the ISS is decommissioned near decade's end, Tiangong will be the only major state-run station in orbit. Since 2024, it's hosted on-orbit validation of over 20 high-performance processing chips from 16 to 28 nanometers. Many are domestically designed by companies like Lungsan, China's competitor to AMD and Intel. These space-hardened chips reportedly outperform processors currently used by other countries in space. Why does this matter? Space-based AI and autonomous systems require robust onboard computing. China is building that capability now in orbit with real missions. Chinese officials confirm plans to expand Tiangong to 6 modules supporting 1,000 science missions over its lifespan, matching or exceeding the ISS's scientific output. China is also preparing mega constellations to challenge Starlink. Guoang, Hongyan, and others could deploy tens of thousands of satellites, plus plans for an orbital solar power station and a Chinese counterpart to the James Webb Space Telescope. As one expert noted, China is living its Apollo, ISS, and commercial space eras all at once. How did they move this fast? 3 possibilities exist. First, legitimate parallel development. China has massive engineering talent, state funding, and clear strategic goals. Second, technology transfer through legal means, academic papers, conferences, employee movement between companies. Third, industrial espionage. The FBI has repeatedly warned about Chinese intelligence targeting aerospace companies. The truth? Probably all 3. But here's what matters now. Regardless of how they started, they're building real hardware that works. The BF-20 fires. Zhuke-2 reaches orbit. The reusability test succeeds. These aren't stolen blueprints. They're operational systems. A recent expert report warns China could overtake the United States as the world's leading spacefaring nation in 5 to 10 years. Not decades, years. That's based on launch cadence, investment trends, infrastructure development, and technological achievements. China launched more orbital rockets than any country in 2023 and is on track to repeat in 2024. SpaceX still leads in reusability and cost efficiency, but China's state-backed model allows sustained massive investment that doesn't depend on quarterly earnings. They can play the long game in ways commercial companies cannot. The question isn't whether China copied the engine design anymore. The question is, what happens when they surpass it? So here's the bottom line. China didn't just copy SpaceX's Raptor engine. They're building 3 different versions that could surpass it. The BF-20 matches Raptor 2's power. Space Pioneer's kerosene engine targets 300 tons of thrust. The state-backed YF-215 is already in full-scale testing. This isn't imitation anymore. This is full-scale competition. This is exactly why the next 5 years will determine who leads in space. When one nation operates 6 spaceports, the only space station, and invests $2.86 billion annually into commercial space, that's not catching up. That's preparing to dominate. And this is just the beginning. Landspace's Zhuke 3 launches in 2025. Space Pioneer's revolutionary kerosene engine could fire within 2 years. The mega constellations are coming. Every quarter brings breakthroughs that used to take decades. Here's what I want to know. Do you think this competition will push SpaceX and NASA to innovate faster? Or are we watching America lose its space dominance? Drop your answer in the comments. This conversation matters. This is Space Hub, where we break down what's really happening in the space industry beyond the hype. If you want expert analysis on the technologies shaping our future in space, hit that subscribe button and turn on notifications so you never miss our deep dives. Like this video if you found it valuable. Share it with anyone who needs to understand how fast the space race is actually moving. Because the question isn't whether China will challenge America's space leadership anymore. The question is whether we're paying attention while it happens.